Welcome to the Star Pencil. Today we will see roots and zeros of the polynomial equations. In the last class we learned about linear equation and its root or zero numbers. Okay, so I am rewriting the linear equation once again here. So if you take a y is equal to p of x, means function of x, y is the function of x, and we write some of the equation last time like 2x plus 3. okay, I not remember exactly, so I'm just writing one linear equation. How do you say it is a linear equation? So it's the max power or power of the variable is 1. okay, then we are calling this as a linear equation. Okay, this is the one, maximum power of x is the 1. So this is called the linear equation or first order equation. Okay, so the linear equation maybe it may vary these two numbers, but order cannot be changed to the more than 1. okay, or it's a 1 first order. Okay, so I'm writing some of the linear equations here. Okay, this is the equation number 1. Another equation I'm writing y is equal to 4x minus 5. Another equation is equal to minus 20x plus 15. So on we can keep writing any number of linear equations. Okay, to generalize the linear equation we will use some kind of constants or coefficients they are calling. Okay, so I am writing, instead of writing here 2 number, here 4, here minus 20. So before the x is there, here is a 2 is there before x, here 4 is there, here minus 20 is there. Like that we can write any number of linear equations. To denote all these numbers, okay, I am writing I am denoting a as the number. Okay, a is the number and the variable is the x, and similarly for all these constant numbers I am denoting with b. Okay, so in the first equation here a is equal to 2 and b is equal to 3. So we have specific name for this. Okay, so b we are calling as the a and b are the constants not the variable, the given equation, but that constant will be different there for the different equations. Okay, but there is a specific name when we are writing this constant before the x. This we are calling the coefficients. Okay, and at the without any variable there is a number, this one we are calling the constants. Okay, so in the polynomial we will call a as the coefficients which is there before the variables. Okay, and which is there separately, that we are calling as the constant, and anyhow both a and b are the constants. But the nomenclature they uses this as the variable, these are the coefficient, and this as the constant. Okay, now for zeros of the equation, to find the zeros or the roots of the polynomial equation, what you do at y is equal to 0, what is the value of the x is called the roots of the polynomial equation, right? So if you make it the y is equal to 0, this is a generalized form of the linear equation, right? Y is equal to ax plus is the generalized form of the linear equation. Here we are making ax plus b is equal to 0. Okay, then you take other side, that other side b, it's become minus b, and then x is equal to minus b by a. What does it mean? For the linear equation of y is equal to ax plus b, okay, roots of this equation is x is equal to minus b by a. Okay, now we will be seeing the quadratic equations. Okay, so what is a quadratic equation? The power of the x is the 2 number is called the quadratic equation. So I will be writing the So what is the quadratic equation? The power of the x is the 2. Okay, so I will be writing some of the quadratic equation. For examples, y is equal to function of x. It is a single variable function, and I am writing some equation like 2x square minus 5x plus 10. Okay, so maximum power of the x is the 2 here. Okay, so then this is we are calling second order equation or quadratic equation. Quadratic equation. Okay, so now we will see how do we find the zeros of the polynomial equation for the quadratic equation. In general form, we can write the quadratic equation something like this: y is equal to ax square plus bx plus c. Okay, so in the above equation, what is the a? 2. What is the b? We need to include the sign also while taking. Okay, it's minus 5. What is the c? It is a 10. Okay, so a, b, c are the constants, but we'll be calling a and b are the coefficients. Okay, this is x square coefficient, this is x coefficient, and this is the constant, right? Okay, now we will see the graphical representation of the representation for the quadratic equation, and how do we find the roots or zeros for this quadratic equation. Okay, now we'll write another polynomial equation. Y is equal to x square minus 3x minus 4. In the generalized form, we have written the quadratic equation, right? Ax square plus bx plus c, right? So what is the a here? Here a is equal to 1, b is equal to minus 3, and c is equal to minus 4. Here 1 minus 3 and c is equal to minus 4. Okay, I am writing in the table form this quadratic equation at the various points. That means x is the variable at various x values. What is the y? We are going to find it. Okay, so this is x. I am writing y here. Okay, y means it is y is equal to x square minus 3x minus 4. I am just writing. I am negative axis to positive axis. I am writing x variables minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, y at the various numbers minus 2. Okay, I am just show 1 or 2, then I will keep writing. You can do it yourself, rest of the things. So at x is equal to minus 2, y is equal to, we need to substitute minus 2 into that equation. So minus 2 whole square minus 3 into minus 2 minus 4. So minus 2 whole square is a plus 4 and plus 6 and minus 4. So that is equal to 6. Okay, so at x is equal to minus 2, y is 6. So I am writing the y is 6 here. Okay, similarly when you do it for the minus 1, we get 0 here, and when you substitute 0 and we get it to the minus 4, when you put it to the 1, then minus 6, then minus 6, minus 4, 0, 6. Okay, now and mark the points whichever we have calculated here at various x variable y numbers, and we will keep the points on this graph. Okay, so at x is equal to minus 2 means this is the x axis and this is the y axis. At x is equal to minus 2, what is the y number? It is a plus 6, right? So where is the plus 6? It is a 6 is the here. Okay, so mark this point. Okay, then at x is equal to minus 1, y is 0. x is equal to minus 1 means here y is 0, so it is touching here. Okay, so this is the point, this is the first point and this is the second point. Okay, then at x is equal to 0 y is minus 4. Okay, this is the point. Okay, okay, at x is equal to 1 y is minus 6. So this is x is 1 and y is minus 6. Okay, this is the point. Okay, then at x is equal to 2 y is minus 6 again. So x is equal to 3 y is minus 4. Okay, and at x is equal to 4 again 0. At x is equal to 5 it is again 6. So I am trying to join all the points here. Okay, so whichever drawn here I am trying to draw the join all the points here. Okay, so this one we are calling the quadratic equation. Okay, so this is the equation. I am just written part of the equation. So if you are calculating y values at minus 3, minus 4, minus 6, so on. Similarly, plus side it's more than 5, like 6, 7, 8, 9. So then we can be extended this graph. Okay, either sides. So I am just drawn the part of this graph. Okay, from minus 2 to plus 5 of the x numbers, that is corresponding to y numbers are plus 6 to plus 6. Okay, now so we say that what is the roots of any polynomial is roots are zeros of the polynomials. When y becomes the 0, okay, what value of the x y becomes the 0 is called the roots of the polynomial equation. So this equation, what are values of the x y becomes 0? You can see here actually. See, all the x-axis y distance will be 0. Okay, you can see this is the x-axis and this y distance will be the 0 along the x-axis. Okay, so what are the points lies on this x-axis? Minus 1 and plus 4. So x is equal to minus 1 and x is equal to 4. With these two numbers, okay, y is 0. Okay, then what we are calling is, for this polynomial equation x square minus 3x plus 4 polynomial equation, roots we have, roots are 1 comma 4. We have the two roots. Okay, so since both roots satisfying the y makes to 0. Okay, clear, right? So with this we observed that, right, whichever having the second order or the quadratic equation has the two roots. Okay, maximum two roots it has. Okay, but linear equation always maximum it has the one root. Okay, but quadratic equation has the maximum of two roots. So 1 and 4 both are making y as the 0 or p of x is equal to 0. Okay, so roots of this equation is 1 comma 4. Now we will write general form for the quadratic equation, that is called y is equal to function of x, and this one we can write as ax square plus bx plus c. Here a, b are the coefficients, c are the constants, right? So how do we get the roots of the polynomial equation? So we will make the y is equal to 0, and that means ax square plus bx plus c is equal to make 0, and we will find the x numbers. Okay, 1. So how many roots it can has the maximum roots for the quadratic equation? It can have the maximum 2 roots or 2 zeros will come. Okay, now we will see what different types of quadratic polynomials you can get. Okay, so the first type is, for example, if we write the in the axis, this is y-axis, this is the x-axis. Okay, this is the x-axis and this is the y-axis. Polynomial can be like this. Okay, other way, this is the x-axis and this is the y-axis. It can be like this. Okay, so this quadratic has the 2 touch points at the x-axis. There y is equal to 0, right? So these two points, so it has the 2 roots. This kind of quadratic equation has the 2 touch points. So this is also having the 2 roots. So if you have another polynomial equation, another quadratic equation is something like this. So this is the x-axis and this is the x-axis, and I am writing 2 different types. This is x-axis and this is y-axis. So polynomial equation can exactly touch the x-axis like this and go up. Okay, or it can another way, it can exactly touch and it go down like this. Okay, so this case it has the only one root. Even it is a quadratic equation, it can have the maximum roots of 2. This case it has only one root or 1 zero, so it will be having. So if you see another case, okay, this is the x-axis and this is the y-axis. So yeah, similarly I am writing 2 axis. So this kind of polynomial quadratic equation will not touch the x-axis at all. It will go like this, or it can go like this, here like this. So these are the 2 quadratic equations. So these 2 equations are the 2 curves. Okay, it is never touching to the x-axis. That means it never become y, never becomes the 0. So this kind of quadratic equation does not have the any roots. Okay, or any zeros. Okay, does not have any zeros. So what we see so far, the quadratic equation can have the maximum roots of the 2. In this case it has the 1 root, this case no roots. Okay, so what we can conclude from above all this, right? So the quadratic equation can have maximum of 2 roots. Okay, now see similar to the cubic equation. Okay, so in the cubic equation I'll write the general form of the cubic equation here. Okay, cubic equation or third order or third degree, anything, third order polynomial equation. Okay, so cubic equation, third order polynomial, general form I am writing. Okay, it is ax cube plus bx square plus cx plus d. Okay, general form. So it has the order 1, order 2, order 3. So maximum order is 3. So that's the reason we are calling this as a cubic equation or third order polynomial equations. What we will call a, b, c here, those are the coefficients. Whichever is there in front of the variable, those are called the coefficients. So here a, b, c we are calling the coefficients, d is the constants. Okay, so I'll read some of the examples for this cubic equations. Okay, for example, y is equal to x cube minus 4x. So this is the equation. Here what is the a? 1. What is the b? Here there is no x square term, that's the reason b is 0. What is c? Minus 4, it has the x term. Okay, what is d? It does not have the d term, so it is 0. So So if we put a is equal to 1, b is equal to 0, c is equal to minus 4, d is equal to 0, we get the equation y is equal to x cube minus 4x. So this is the cubic equation. Similarly, I am not going to repeat everything here. Similarly, if you keep varying in this equation, I am keep varying the x is equal to minus 2 to minus 1, 0, 1, 2, 3. If you keep putting x is equal to these numbers, how much y you get? Put minus 2. Just putting it x is equal to minus 2, I am putting minus 2 cube minus 4 into minus 2. So the minus 8 plus 8, so it is 0. So at x is equal to minus 2, y is 0. Similarly, at x is equal to 0, put y is equal to 0, and even x is equal to plus 2, put in this equation, we get y is equal to 0. So for roots of the cubic equation, it has the 3 roots. Okay, what is that 3 roots? What is the 3 roots? X is equal to minus 2 is the one root, 0 is the one root, and plus 2 is the root. These 3 roots are satisfying the cubic equation. So what do we know? That in the cubic equation it can have the maximum of 3 roots. Okay, so this equation has the 3 roots now. Okay, minus 2, 0, and 2. Okay, so even it can have the 2 roots, even it can have the 1 root, or even it has the 0 roots, but it can have the maximum of 3 roots. So these equations can be written something like this. Okay, so I'll write up some x-axis and y-axis here. So the equation can go like this, randomly like this. Okay, so that it is touching the x point, maximum it can touch 3 places. When it has the cubic equation, it can touch maximum. So equation also in order to be touched like this, so it can go like this also. Okay, that time it has the 2 roots. Okay, even it can have the 1 root also, but in the cubic equation it can have the maximum 3 roots. Okay, now I will show you some of the polynomial equations, and can you find how many roots has each polynomial equations? Okay, from the graphical representation. So in the below graph I have shown the 6 graphs here. So in each, this is the polynomial line. Okay, so how many roots it has? It is not touching anywhere into the x-axis. So when it touches the x-axis only, that will become y is equal to 0. So for what value of the x y becomes is 0 is called the roots of the x. Okay, so this one, whatever the value of the x, is never touching the y, or y is never becoming the 0. Okay, it's going parallel to the x-axis. So this one does not have the any roots. Okay, so it has the 0 roots. Okay, so this is another equation. So this equation, when it's going here this way and going here and going here, so what is the touch point for the x-axis? Only at one x is equal to 1 row, 1 number, then y is becoming 0. So it has the only 1 root. Here it is touching at 3 places, so it has 3 roots. Similarly, this is touching at the 2 locations, so it has 2 roots. This one 1, 2, 3, 4, it has the 4 roots. Okay, it is touching how many? 1, 2, 3. So it has the 3 roots, right? So this way you can find the number of roots. So wherever it is touching to the x-axis, that means that there it will y becomes 0. Thank you.